Hello, this is a problem that one of my students sent to me, and we are to write a polynomial function to represent the perimeter of this shape that you see outlined here in red. So what we have is a situation where we start out with a rectangle that measures 15 inches by 8 inches. 15 is, of course, the length, 8 is the width. And we're cutting out squares on each of the four corners, and each of those squares measures x inches on a side. And there is a little bit of a restriction on the domain of x. X is going to have to fall between 4 and 0 because this limiting side is the width 8. So if you cut out 4 inches on one side for a square and 4 inches on the other side for a square, then you've cut out the entire width. So that 0 to 4 is our limiting domain factor on this. All right, so how are we going to go about writing an expression, a polynomial expression, to identify the perimeter of this that we see in red? Well, what I'd like to do is start with this distance here from, let me see if I can highlight that for you, from here to here. There we go. So we'll be talking about that little section right there. If you notice, we start out with a full length of L from corner to corner, and then we're cutting out a little piece on each side that measures x inches for each of those two squares that we're going to cut out. So what happens when I look for the perimeter, the length of this highlighted yellow, is we start with the length L, which is the total distance, and we subtract out two x's, an x from one corner and an x from the other corner. Now if I go in here and look at, let's say we look at this little stretch right in here, on the width side, we see that we have a full distance W for the width, and again we're subtracting out an x from one corner and an x from the other corner. So let me see if I can do a rough sketch here of where we are. So now we have this sort of unusual shape that looks something like this. Ooh, this is not a very good drawing, is it? All right, so this distance is L minus 2x, and so of course we have another one up here that's L minus 2x, and this distance is W minus 2x, and we have another one on the other side that's W minus 2x. So we've got those four side lengths accounted for. Let me start my polynomial function. So I have a W minus 2x, and I'm going to multiply that by a factor of 2 because I have one on each side. This is perimeter, so I'm adding. I have another length that is L minus 2x, and I'm also going to multiply that by a factor of 2. And now I've got to account for these last little corners here. So each of these that I'm highlighting in red measures x. And remember, you get the perimeter by adding up the sum of all the lengths of the sides. So let me see how many x's I have. I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm adding on those 8x lengths for those 8 little sections of the perimeter. So remember, I'm adding all these sides together. All right, so I think I've got my polynomial expression written, but it wants it in terms of x. So I want to go in here and take each of these things, each of these variables that's not an x variable, and I'm going to replace it with the number that we were given. So here we go. Polynomial function in x, 2 times, remember the width was 8. And then I'm just copying. and going in here and replacing L with 15. And now I believe I have everything just in terms of that single variable x. So remember, when you use this function notation, the letter that you see in the argument, in the parentheses, p of x, should be the only variable that we see over there on the right-hand side of this polynomial function. So now I think it's just a matter of working through the algebra. So I'm going to distribute this 2. And I'm noticing here that I have several x terms. So I'm going to combine those x terms, and as I look at the combination of those x terms, I believe that all adds up to 0x. So we end up with just a number, and that number looks like it's going to be 46. And it's interesting to me that that number 46, if I had taken the perimeter of the original rectangle before I took out those corners, cut out those corners, I would have arrived at that same number. And of course, this is in terms of inches, 46 inches. So I'll leave you to think about that, why we ended up with the exact same perimeter on the cutout shape as we had on the original shape.